Now let's say you have a need to make a cryptographically secure random number. It's kind of a catch-22 because to be cryptographically secure, it's not really random, but it's still random. It's kind of a weird concept, but bear with me here. So the difference between a random number and a cryptographically secure random number is that you can actually predict, to a certain extent, the randomness of the cryptography. Whew, that is confusing. All right, so let's make a uint8 list, random bytes. So what would you want this for? Well, let's say you work in something like the gaming industry, like a casino or something. You would need something that's verifiably, cryptographically, securely random, and that's what we're doing here. So let's say final, R&D, new, and we're going to say secure random, and we need to give it some algorithm names here. So we're going to say AES, CTR, and let's say auto seed PRNG. So what is this doing? Well, it's just doing an algorithm chain. It's saying AES, CTR, and then auto seed. Auto seed means that, like the salt, it's going to randomize it to an extent. All right, so now that we have that, let's say final, and let's call this key. And we're going to make a 16 length. We want to make a new key parameter with the key. And from here, what we want to do is a parameters with IV. Now, what that stands for is a parameters with initialization vector. Think of an initialization vector as, well, like the salt. It's very similar. You have a list of numbers, and that's really all we're doing here. So we're going to say key param, and here we want a uint8 list, and we want 16. All right, so let's make this new. Let's seed with our parameters. And don't worry, I'll explain all this gibberish in just a second here. Sometimes it's a little challenging to type and talk at the same time. Encryption is very complex and it can kind of bend your brain at times. So we're going to say next bytes. All right. And then we're just going to return the bytes. So let's look at this little beauty of code here. What we're doing here is we're saying we want a new secure random. We're going to chain it through some algorithms. And then we've got a key, which is going to be just a blank list. Key param, well, that's just a key parameter. So pretty much we're just taking that list and shoving it into another variable. Then we have params, which is taking the key param, which is basically the key, and adding another one called the initialization vector, or the IV. And then we're going to seed that. Now what we do here with seeding is we're taking these parameters and adding them in. Random equal new random. Then we're just going to say, hey, grab a random number between 0 and 255 and grab the number. And then we're just going to say the actual random next bytes. Whew, that is a lot of typing. So what does all this actually do under the hood? Well, it takes the key, it takes the parameters, it combines those, and then it seeds this random generator. The generator then has these algorithms, it passes it through, and you get a giant list of numbers that you can use. And then it returns the bytes. Let's go ahead and do this. So let's just say print random bytes, and we want a list of 8. Let's run this. And there it is. Now, if we run this multiple times, you can see how the numbers are random. There are some minor flaws in this, as there are with any cryptographic program. For example, we're saying random equal new random right here. Well, what if this Dart version of random isn't actually random? Well, then you can do what's called a numbers prediction, meaning you can kind of guess what's going to happen. That's why you're doing this chaining up here, to try and avoid that. All right, now what would you use this for? Well, key generation. We just talked about building a secure password. Sometimes you can't trust the user to build a secure password. Sometimes you need to generate one yourself. That's when you would do something like this. So let's just say we wanted a 16-bit password. There's our 16 random numbers.